So why don't you guys try this problem before I show you how to do it? So pause the video and try it because the explanation will be given in 3, 2, 1. So here we have a growth model. So we know that we have something that looks like this. The initial amount is 10. The interest rate or the rate of growth is 3.5. So we have something like this. Now, the time, okay? The exponent. Recall that t has to match r. R here is measured in terms of 4-month blocks of time. I know we're talking about 2 years, but how many 4-month blocks of time fit into 2 years? Something like this. I drew a little example here. So I have 2 years, but each year can be broken up into 3 4-month blocks. So how many clusters of 4 months can we fit into this? 6, okay? That's why this should be 6. From here, we go Casio. So we have something like approximately 12.29 pounds, okay? Something like that. All right, why don't you try this one here? Okay, so take a look at it, pause it, try it. The explanation in 3, 2, 1. Okay, so this is, we have compound and it says every 3 months. So I know that it's Decay compound model. What is the investment? We invest $10, 1 plus. R is the rate. It doesn't say, so it says R, so I'll just leave it R. K is the number of compounds per year. The money's compounded every 3 months. If something happens to you every 3 months, how many times does it happen per year? That many times. Copy and paste. And then T is always years when you're talking about compound. The years is 10 because it says a decade. I don't know R, but I know the amount after 10 years is 100K. There we are. The goal is to find R. So let me just run right through this. For this problem, the interest rate was 103.57%, so it grows rather quickly. Why don't you guys try this problem here? Because the explanation comes to you in 3, 2, 1. So first I'll go through and rewrite everything in terms of 6s, right? Let's rewrite everything in terms of 6. And now we can do a couple of little things. Okay, we can do some more. We can combine these into a single 6 by adding the powers together. We can simplify the exponent here. And now we can dismiss the 6s and go this equals that. And this, of course, implies that W equals, is that a half? That's 1/2, right? W equals 1/2. Let me try one more. So how about this one here? So give it a read. And the explanation comes in 3, 2, 1. So this looks like it's going to be, what is this? This looks like it's decay, right? This is going to be decay. A equals A naught, 1 minus R to the power of T. It says that your math grade goes down to this much after some time. We don't know the initial grade. I don't know what the initial grade was, but you stop to study and then time passes and your grade drops to 63. So that's 63 is your grade after some time. We don't know the original grade. 1 minus R is 2%, so 0.02. Now, the 2% is every week. And how much time passed? What was the time that passed? 8 months. So remember, this has to agree with this in terms of how time is measured. R was measured in every week, weeks. So 8 months passed. So 8 months would be how many weeks? That'd be 32, right? Okay. So let's go Casio on this part here. And now we can divide both sides by that number. So the initial grade was 120.2558264. Now what does this represent? That represents the grade that you had in your math class. So about 120%. So you had over an A+ in this math class, but you stopped studying, and 8 months later, your grade went down to, what is that, like a D- or a D? Something like that. So this was your grade in math class before it all started. To graph something like this, recall that here you have your horizontal asymptote, -7. So you go down to the y-axis at 7, negatives. And that would be your dotted line. All right. Now for here, we go to a table. And what you do is you look at the exponent. You set the exponent equal to 0. And whatever that is, that gives you h. And that is what you put in the middle of your table, -4. Count before, count after, go Casio for that, right? Get some decimals. Plot your points here and connect the dots. Now, I don't have to make a table to tell you what the general shape of this is. You see, this is positive, and this is decay. And positive decay tends to look something like this. The actual graph will slightly differ, more than likely, but it will look something like this because this is positive and this is between 0 and 1, which means this is positive decay. Okay? But again, rely on your calculators to tell you what this is here, round these numbers to the nearest 10th or 100th, scatter the points about, and they should look like whatever classification you get from here.